Welcome back to another episode of Data Insights. Today we're diving into the intriguing realm of graph-like data models. We'll explore how these models differ from traditional relational schemas and why they're gaining traction in various applications. Whether you're a data enthusiast or simply curious about data structures, there's something here for you. Let's kick things off by looking at the limitations of traditional relational schemas. Picture trying to represent different regional structures across countries. In France, for instance, we have département and région, while in the United States, we have counties and states. This diversity makes it pretty tricky to fit all that information neatly into a relational database. Now think about someone like Lucy. She lives in a city, but her birthplace is recorded at the state level. This difference in granularity can complicate how we represent data using traditional relational models. That's where graph databases come into play. They provide a flexible structure that allows us to express relationships and hierarchies more easily. For example, we can represent Lucy's allergies by creating vertices for each allergen and connecting them with edges to indicate her specific allergies. This setup makes it simple to query which foods are safe for her to eat, demonstrating the adaptability of graph databases. As our applications evolve, we can extend these graphs without major restructuring, making them perfect for dynamic environments. Speaking of querying, let's talk about how we can access this data. Graph databases typically use a query language called Cipher. If we want to find people who emigrated from the United States to Europe, we can write a query that looks for vertices with a born-in edge pointing to a US location and a lives-in edge pointing to a European location. This method allows us to traverse relationships without needing to know in advance how many joins are necessary, which is often a requirement in SQL-based queries. To illustrate this, let's break down a Cipher query. It starts by identifying a person vertex with a born-in edge leading to a US location and a lives-in edge leading to a European location. The beauty of this approach lies in its ability to allow variable traversal of edges, something you don't typically find in traditional SQL queries. You might be wondering how this compares to SQL. While it's possible to express graph-like queries in SQL using recursive common table expressions, the syntax can be quite cumbersome compared to the elegance of Cipher. For instance, to find those same emigrants, you'd have to set up multiple temporary tables and complex joins, which can quickly become unwieldy. This brings us to triple stores, which are closely related to graph databases. In a triple store, all information is stored as simple three-part statements: subject, predicate, object. For example, in the triple, Jim likes bananas. Jim is the subject, likes is the predicate, and bananas are the object. This structure provides a clear representation of relationships, much like vertexes and edges in a graph. In a triple, the subject corresponds to a vertex, while the object can be either a primitive value or another vertex. This duality allows for rich data representation. For instance, if we have a triple, Lucy, married to Elaine, both Lucy and Elaine are vertices connected by an edge labeled married to. One popular way to represent these triples is through a syntax called turtle, which makes the data quite readable. We can represent Lucy's information in turtle format, showcasing her relationships and properties concisely. This readability is a significant advantage of using triple stores, especially when dealing with complex data relationships. However, it's important to note that while triple stores and graph databases share similarities, they cater to different use cases. The choice of data model should align with your application's needs. If you're developing an application that requires extensive relationship mapping and querying, a graph database might be the way to go. On the other hand, if you're working with semantic data and need to integrate information from various sources, a triple store could be a better fit. Let's also touch on the semantic web, often associated with triple stores. The Resource Description Framework, or RDF, was designed to enable consistent data publishing across the web. However, the vision of a fully realized semantic web has faced challenges, leading to skepticism in the tech community. Still, the triple store model remains valuable for internal data management, even if you're not focused on publishing data on the semantic web. As we wrap up today's episode, it's clear that graph-like data models offer a flexible and powerful way to represent complex relationships in data. Whether through graph databases or triple stores, these models allow for more dynamic querying and data representation compared to traditional relational schemas. Understanding these data models is crucial for developers and data professionals as applications continue to evolve. Thanks for joining us on this exploration of graph-like data models. If you found this episode insightful, be sure to subscribe for more discussions on data and technology. Until next time, keep questioning and exploring the fascinating world of data.